So one of the things about the HeatPumPro is it's actually good for anything from a single stage conventional piece of equipment all the way up to a dual fuel application. The really nice thing about the HeatPumPro is you don't need any specific thermostat. It just needs to be heat-cool thermostats and just needs to be single stage thermostats as well. This panel will control all of the staging internally, and this is how we actually operate and control your Y2 output and your W2 output on the panel. So there's really three things to kind of keep in mind when you're breaking up a home into zones is what size is the zone, what size is your equipment, so how much CFM we're actually supplying to the zone, how big your equipment is in tonnage, and that's going to be your blower motor tonnage, and then which zones you want to actually group together is the biggest things that you want to consider with zoning. So one of the big things is, can your equipment actually handle Y1, Y2 operations? So can it handle a second stage operation, or is it too small to handle that full CFM output? So with the HeatPumPro, the way that we actually handle this is we have separated Y1, Y2 and Y1, Y2 condenser and air handler terminals. So we're able to independently control the staging of your outdoor and indoor unit. And the way the HeatPumPro does this is the indoor unit is all staged based on your zone weighting feature. And we'll get into that here and how that actually operates. And then your outdoor condenser unit, whether it be a heat pump or just a straight AC, it's all done on ductwork temperature and time. So there's two settings in the HeatPumPro. One's a heat stage threshold. The other is a cool stage threshold. Those are the temperatures that you're looking to maintain in the ductwork before we upstage the outdoor unit. So if after 3 minutes you're not able to hit that heat or cool stage threshold, the panel will upstage to second stage and kick on your condenser to second stage output. And then the indoor unit is all based on zone weighting. When you guys are looking at your jobs out there, so these are just a couple examples of your typical homes. This is going to be your typical 2-story house. So you got a zone 1 and zone 2. Some of the things to kind of consider when you are splitting up zones is you want to do a load calculation on both zones to make sure that they're, somewhat equal if you're splitting into 50-50 split like that. You also want to take a look at how many CFM outputs. So see if you have the same amount of CFMs or not. And this will help you better determine what size bypass you're going to need, or if you're going to need a bypass at all. If you guys can, the best thing to do is utilize that zone weighting feature and try to minimize the size of the bypass or get rid of the bypass completely. So that's really what we strive for, and that's really what we're going to be touching on in this presentation here. So if you guys will take a look at this example here, this is a 3-story ranch. So if you're looking at your zones, they look all somewhat even here, but do you think that zone 3 would have any kind of complaints, or possibly even zone 2 for that matter? I mean, it really depends on how many ducts you have. So say you only had 1 or 2 6-inch runs going to that bedroom in zone 3. It's really not the best possible thing to make that its own zone. A lot of times you can achieve the same thing with a slave. That way you don't have that small of CFM in that ductwork, and you're able to join that zone with any other zone before you get equipment control. So there's a lot of things to consider when you're operating and taking a look at a home. Typical residentially, you're not going to really go over 4 zones. At least we don't like to see it go over 4. There are going to be your exceptions on the really big homes, but your typical residential, 4 zones or under is really where we would strive for you guys to be. That way you're not getting those minimum zones, those micro zones, and having issues with your equipment and, just overall non-comfort for the customer. So kind of when you're looking at a house like this, when you got a small master suite and a family room, you'd be almost better off doing slaves, or at least, I would not do this kind of job unless you have a 2-stage equipment, and then you utilize that HeatPumPro zone weighting feature. If you do that, you can definitely zone a home very similar to this and still achieve the outcome that you're looking for without pushing your equipment past the limits. So with the HeatPumPro, the settings that you're going to be looking at for zone weighting is each zone will have a weight percentage, and then you're going to have an air handler stage threshold. These are the settings that actually play off each other on the HeatPumPro to lock out the second stage operation on equipment. So a couple of examples. The way that your zone weighting works is you're going to assign a percentage of ductwork per zone on your equipment. So say you have a 4-zone panel, you assign each of your zones. So you got a 50 for your zone 1, 40% for zone 2, 20% for zone 3, and 20% for zone 4. And like I said, the zone weight plays off your air handler stage threshold. So if you had your air handler stage threshold, the way this actually works is if your zone weight is equal to or greater than your air handler stage threshold, it allows for second stage operation. If your air handler zone weight is less than your air handler stage threshold, then it locks out second stage operation. So for the first example there on the left, that you got a 50% air handler stage threshold, when you look at zone 1, the weight is set to 50%. So on your zone 1, you're going to be able to allow first and second stage output on zone 1 by itself. When you go over to zone 2, you got a 40% zone weight. So if this zone was calling by itself, it will not be able to go into second stage operation at all. It would rely on one other zone, and it could be any zone in this panel, to call with it to equal that 50%, and then it'll allow for second stage operation. And then when you guys are looking at zone 3 and zone 4, we both have 20%. So neither of these zones can go into second stage by themselves. They're also cannot go into second stage if they call together. So zone 3 and zone 4 call together. You're still not going to get second stage operation. But if any combination of zone 2, zone 3, or zone 2 and zone 4 call together, you'll be able to get second stage. So it's really, that's how you guys need to look at it. It doesn't really matter the percentage that you assign for that zone. It's more so, does it equal that air handler stage threshold, or is it less than the air handler stage threshold? So the next thing that we did here, this is a test station that we have set up in our lab. It's a 5-ton system. It's going to be in a Mana. It's a GMVC 96. So it's a variable speed 2-stage furnace that we have back there. This is not wired up to be communicating. It gives you the option of that. So this is just first and second stage outputs. So it says the communicating feature taken out. It's just relying on a Y1, Y2 output or a W1, W2 output. And on this system, we have one 16 by 10 trunk damper and 9 6-inch rounds. And this is going to be a 5-ton system. So it gives us our 2000 CFM of ductwork. And these are just some static readings that we were doing. So on your typical 5-ton blower, non-zone system, and these are our test results back there. So on a Y1 output, we were able to maintain a 0.19 total external static pressure. And then when we were exceeded to our second stage output for cooling, we were able to maintain a 0.49. And this is without zoning completely, so this is all the ductwork open up 100%. So this is what you would look for before you start zoning a piece of equipment. Is this is a pretty well balanced piece of equipment. It's maintaining its static where the equipment manufacturer wants it. So we know if we had zoning, we're not going to push this equipment past the limit. So when we do start zoning it, so this is going to be 45% of the trunk closed off. So we're going to close off the one zone. When we did that, our Y1 output, we got a 0.22 total external system pressure with 122 watts as on our blower motor. And then our Y2 output was 0.6 total system static, and 520 watts was our blower output. So you can see that difference just between Y1 and Y2 with the zoning on how much of a difference that static pressure is going to do, and your wattage is going to increase when you're doing that Y2 output on those zones. So this is, a pretty typical 2-zone system. When you're going into locking out another zone, so essentially we're dropping this to 35% of our equipment potential, so our actual smallest zone is no smaller than 35% of the duct here. This is really what you're looking for if you guys are doing a PSC motor. If you guys are zoning that piece of equipment, you never want your smallest zone smaller than 35% of your overall trunk. Just a rule of thumb, and that's with a minimal bypass. Just keep that in mind. But with this setup here, with our Y1, we were able to maintain that 0.3 static and a 0.69 on Y2, and the difference in wattage is 138 to 550. So this is essentially dropping it down, locking in the first stage. You can see the difference in wattage, but our feet per minute is not that far off. We have 830 feet per minute on first stage with the same thing, and then we have 1,375 with the other zones open and a Y2 output. So our next one that we did here is we only dropped it down to 2 zones calling, so this is 25% of our trunk. This is the smallest that we ever really want to see a zone, unless you guys are doing a slave function or something like that. But typically 25% on an ECM style or variable speed piece of equipment is your smallest zone. And that's going to be with a minimal bypass as well. So that's another kind of rule of thumb for you guys. 25% on ECM, 35% on your PSC motors or a belt driven if you come across that still. So with this example here, when we were locked into first stage, we're at a 0.38 total external static pressure with 166 watts and 875 feet per minute on the registers themselves. Then on our Y2 output, you can see our total external system pressure is actually exceeding the maximum now. So we're at 0.8, typically about a 0.7 is what we strive for with zoning. Still, pay attention to your manufacturer's nameplate. You never want to exceed their maximum static on the equipment. So they're always going to have a, 0.5 as their, desired, and then they're going to have a maximum. You just want to make sure you're under the maximum. So typically about a 0.7, 0.75 is really where you're looking for that total system static pressure. And then with your wattage, you can see 605 watts. So you're using much more power and only 1,434 feet per minute out of the register. It's really not that much of a difference. And then our last example, which we would never really want to see a zone this small, but this is a 5-ton system. 15% of your trunk is actually open still. And you can see 0.485 is our total system static. 0.92 on a Y2 call. Then you got 197 watts and 679 watts for your Y2 output. So what does this kind of mean to you? So this is kind of what you're looking at here. On your average CFM for your Y2 on 100% ductwork is 95 CFM. 467 watts is what you're using. So this is 100% of the ductwork open. Y2 outputs on the panel. And then when you are zoning it, if you drop off, 50% of that ductwork, just on your single Y1 call, you're able to stay under the wattage of 122 watts. So you essentially achieve the same CFM in those zones, but you get it for a lot less. So zoning does create a little bit of energy efficient. It's hard to prove exactly what you're going to save, but you can save money, and these test results do show that. I mean, if you stay in that Y1 output, it's about a 300% savings. Not that you're going to run it that long. I mean, this would be if you were running a Y1 output 100% of the time. So you're not going to save that, but you can see the money savings is there. You're able to achieve the same CFM output delivery with less equipment capacity. So you got a 4-zone panel, air handler stage threshold of 50%. Your zone 1 is set to 50. That's going to allow for second stage output. When you're going into zone 2 at 40%, second stage is going to be disabled because we cannot hit that air handler stage threshold. We're less than that. When you get into zone 3, 20%, we're still under 50. We cannot go into second stage. But if zone 2 and zone 3 call together, it gives you that full equipment capacity. And then that last zone, it's going to be the exact same as zone 3, so it's got to call with either zone 2 or zone 1 to get full second stage output. If zone 3 and zone 4 call together, you still will not get that second stage.